The next problem of the 8 problems in the set, the second problem, involves 2 squares, and we know that the diagonal of one is 8 and the diagonal of another is 9. So we'll call this D, so 8 is the diagonal here and 9 is the diagonal here, and actually we might call this D1 and D2. I didn't put subscripts on them. There's some side S1 and some side S2 on each of these squares. And of course the area is going to be the square of the side. However, we don't know exactly how to find the area in terms of the diagonal. It's not that hard to figure out with the 2 equal sides and using the Pythagorean theorem, but we're going to leave that alone for right now. So for the moment we're simply going to say that we do know, though, that the area is proportional to the square of the diagonal. If the diagonal was to double, the dimensions of the square would double and the area would then quadruple. And we also note that the ratio of your diameters of D2 here to D1 here is the same as the ratio of the sides, because these are geometrically similar figures. And this also justifies the idea that the area is K times the square of the diagonal. However, the main idea is that the diagonal is a linear measure. It's a measure of distance. And that measure characterizes the side of the size of the rectangle, of the square. And since we have a linear measure that characterizes the size of the square, the area is going to have to be proportional to the square of that measure. So in this case, things are going to start looking a little bit familiar here. The ratio of the areas of 2 squares is going to be the ratio of the KD squared. So KD2 squared over KD1 squared. Of course, K cancels out, and we end up with D2 squared over D1 squared, which is just the quantity, D2 over D1, quantity squared. So that the area ratio is the same as the square of the diagonal ratio, the ratio of the lengths of the diagonals. In this case, that ratio, of course, is 9 over 8. So to get the area ratio, we square the 9 over 8, and we get 81 over 64. And this is approximately 1.27. I've got a question mark there because I kind of did that in my head, but then somebody in the class said, yeah, that's right. So if we can believe them and have any faith in my estimate, maybe that's correct, but you should check it out yourself.